Hey everybody, my name is Chris and I'm a tutor here at Chegg.com and I mostly do math and computer science. And in this video, we're going to do an example of finding the arc length of a curve. So our curve is y equals the natural log of the secant of x, and we're on the interval from 0 to pi over 6, and we want to find the arc length of this curve on this interval. Now remember, the arc length formula in general says the length capital L is equal to the integral from a to b of the square root of 1 plus y primed squared dx. Right, so we're going to have to figure out what y primed is, and we know y is the natural log of the secant of x, so let's go ahead and figure out y primed. So y equals natural log of secant of x, so that means y primed equals, well, from the derivative rule for logs, that's just 1 over the secant of x, but then the chain rule says we have to multiply by the derivative of the secant of x. Okay, so that's going to give us 1 over the secant of x multiplied by secant of x times tangent of x. So remember, that's the derivative of secant of x. And then the secants cancel, that's nice. And then we're just left with the tangent of x. Okay, so what that means then is that y primed squared is just tangent squared of x. So that's nice. Okay, because remember, y primed is tangent of x, so if we just square that, we just get tangent squared of x. Now going back over here, we have the integral. What's a and b? Well, we're just given a and b. A is 0, b is pi over 6. The integral from 0 to pi over 6 of the square root of 1 plus tangent squared of x dx. All right, now how do we proceed? What do we do next? Well, 1 plus tangent squared of x, remember, that's one of the Pythagorean identities from trig, and that simplifies actually to, well, first we have 0, the integral from 0 to pi over 6 of the square root of what? Well, 1 plus tangent squared of x is equal to the secant squared of x. So that's one of the Pythagorean identities. That's the secant. Let's go ahead and fix that. Secant squared of x, and then we still have dx out here. Now we have the square root of secant squared of x, so we have the integral from 0 to pi over 6. Now the square root of secant squared, technically speaking, that's going to be the absolute value of the secant of x, and then dx, but because we're on the interval from 0 to pi over 6, secant of x is always positive anyway, so we don't have to worry about the absolute value signs. And you may be wondering, well, why did I even mention it? It's because I do want to make sure that you keep that in mind, because you might be on an interval where maybe that actually matters. So you want to be very careful about that. Okay, now how do we proceed from here? Well, from here we can actually just use the integral formula for the secant function, and the integral formula says this is equal to the natural log of the absolute value of secant of x plus tangent of x, where x goes from 0 to pi over 6. Right, and this is just the formula for integrating the secant function. If you're unfamiliar with it, it's relatively straightforward to prove once you realize the goofy trick that you're supposed to do here, but that's a topic for a different video another day perhaps. And anyway, if we want to evaluate this, this is now going to be, I think we need a little more room. Let's go ahead and go to page 3. So we have L equals, so far we have the natural log of the absolute value of secant of x plus tangent of x from x equals 0 to pi over 6. So let's go ahead and evaluate that. That's the natural log of the absolute value of secant pi over 6 plus tangent of pi over 6 minus the natural log of the absolute value, of secant of 0 plus tangent of 0. Alright, so evaluate at the top and then subtract and then evaluate at the bottom. Alright, so then this equals natural log of what? Well, we have to start figuring this stuff out now. So secant of pi over 6, what's the secant of pi over 6? This is just a matter of knowing the unit circle, and the secant of pi over 6 is going to be 2 over root 3, or technically 2 root 3 over 3 if you're into rationalizing the denominator. I am not. And then the tangent of pi over 6 is going to be 1 over root 3. and then minus the natural log of the absolute value of what's secant of 0. Secant of 0 is just 1, and then plus tangent of 0. Tangent of 0 is just 0. All right, so then if we simplify a little bit, now we can actually drop the absolute value signs because this is all positive in here. So we just have natural log of 2 plus 1 over root 3, and then minus the natural log of 1. And natural log of 1 is actually just 0, so this whole term right here is 0, so that's nice. So then this equals what? Natural log of 3 over root 3. And actually we can simplify that, so if we want to rationalize the denominator on this, then we're going to get 3 root 3 over 3, which simplifies to root 3, or we can think of that as 3 over root 3 equals root 3 squared over root 3. So then cancels with one of those, and we just end up with root 3. However you want to think about it, we end up with the natural log of the square root of 3. And yes, you could use properties of logs to write this in different forms, but anyway, we'll just leave our answer like that. So this is going to be natural log of the square root of 3, and that is our final answer. That is the length of this curve, y equals natural log of secant of x on this interval here. All right, so this has been an example of finding the arc length of a curve on a given interval. And again, the answer was natural log of root 3. And I hope you found this video helpful, and thank you for watching.